Continuing on with our applications, this is now section 1.7 part 2. Let's take a look at example 2. So example 2 reads, a tea manufacturer wants to market a new blend that sells for $5.50 per pound by mixing Earl Grey that sells for $6 a pound with some orange pekoe that sells for $4 a pound. One amount of each tea should be blended to obtain the desired mixture if the manufacturer needs to mix 100 pounds of the new blend. So it says mix in there multiple times. So this is a mixture problem. So this is category 2. And again, I'm going to use a chart. It's a very similar chart to the one that we just used. So you have a column is the amount. Now, in this case, instead of being dollars, it's going to be pounds. So it's how many pounds we're using. We have a rate, but it's not an interest rate. It's a price per pound. So this is dollars per pound. And then on the end, we'll do the same thing again. We're going to take the amount and multiply it by the rate. So what we're considering to be a rate is slightly different than an interest rate, but it's still how much you're gaining from that poundage, in this case, the amount. Okay, we're mixing together two things. So in this case, I'm going to be specific. So I have my Earl Grey, and then I have my orange beef. So solution 1 and solution 2. And then at the bottom of that is my total. And we're going to start putting our numbers in. So they throw at me 3 different rates, a $5.50 a pound, a $6 a pound, and a $4 a pound. It says specifically that the Earl Grey is $6 a pound. So I'm just going to put a 6 in there. The orange pekoe currently sells for $4 a pound. Our new blend, we want to sell for $5.50 a pound. So it's going in there. The one thing to notice about these mixture problems is the rates are very specific. So the first 2 don't matter, but that third one's really, really important. So I like to think this is something strong or expensive with something weak or cheap, and you're going to end up with something that's in the middle. So think about mixing, water with the Kool-Aid packet, right? So the Kool-Aid packet's one color, the water's another color. When you mix them together, you end up with another color, and that color is in between the other 2. So that's what we're going to think about this as. Okay, what do we know in terms of amounts? Well, the only thing we know is we need a total of 100 pounds. I do not know how much Earl Grey, so I'm going to call that X. This is similar to the last example we worked. So in order to figure out the poundage of orange pekoe, we're going to take the total of 100, and then we're going to subtract off that X. We'll multiply across. So this is 6X. This is going to be 4 times 100 minus X. And then down here, we didn't do this last time because we didn't have a rate in that middle column. We had a total already. This time we're going to have to get the total. So we're going to do the 5.5 times 100. We're going to write the equation doing the same thing using this last column. So we have 6X, that's our first mixture, plus our second one, which is 4 times 100 minus X. And that's going to be equal to 5.5 times 100. And there's our equation. Now we can go solve it. Again, it's a linear equation, fairly straightforward. So we'll distribute first. So 6X plus 400 minus 4X is equal to 550. That's 2X plus 400 equals 550. We'll move the 400 over. That's going to give me 2X equals 150. And then divide by the 2. So X is equal to 75. Woohoo, very nice solving. What is that? So I come back to my chart, look at my chart, and see that X is the Earl Grey, and it's how many pounds of Earl Grey. So we're going to need to mix 75 pounds of Earl Grey with, and now I have to stop and think, right? I need to figure out how much orange pekoe. Well, the orange pekoe is 100 minus the 75. So 100 minus 75 is 25. So we know we're going to mix 25 pounds of the orange pekoe. And there's our answer. So a mixture problem, very similar in nature to those interest problems. So I kind of lump them together in my brain. Okay, let's go do a uniform motion problem. So this is example 3. So example 3, switches gears on us. So it says a motorboat heads upstream on a river that has a current of 3 miles an hour. The trip upstream takes 5 hours. The return trip takes 2.5 hours. What's the speed of the boat? We're going to assume that the boat maintains a constant speed relative to the water. Okay, so I look at that. The first thing to notice is to classify it. I've got something going upstream and something coming downstream. That's what makes it a uniform motion. And we're going to use this distance equals rate times time formula. We're going to note right off the bat that the speed of the current that the river is going at 3 miles an hour. What we're looking for is the speed of the boat. You can use any letter. I'm going to use B for boat. So I'm going to let B be the speed of the boat. And the reason to write that down to begin with is to remind me of what I'm solving for. Okay, so this time the chart's going to look a little bit different. So we're going to have D for distance. Then you're going to have an R for rate. And the rate in this case is a speed in miles per hour. And then the final column is time. So with this time, we have distance. We still have a rate, but we have time. And don't forget that distance is rate multiplied by time. That's going to come into play here in a minute. Let's be descriptive again about what's going on. So our boat is going upstream and it's going downstream. So far, so good, I hope. Okay, well, what do we know? Well, we know that when we go upstream, that the river is fighting against us. So we're going to go slower. So I'm going to put a little slow over here. If we're going downstream, the river is pushing us along and it tends to speed us up. So we're going fast. That's going to help me get this column correct. So if I'm going slow, I have my speed of my boat and I'm going to take away the speed of the current because it's fighting against me and slowing me down. So however fast my boat is going, I'm going to go 3 miles an hour. Slower than that because I'm going against the current. When I'm going upstream, it's the speed of the boat plus the speed of the current. It's the boat plus the current is speeding me up. Okay, the other things we know is that when we're going upstream, it's going to take us 5 hours to go upstream, but only 2.5 hours to come back. Okay, that's all the numbers that they gave me. They didn't give me any other numbers. So in this case, there is no row of total. So I don't have a third row down here at all. I might, but in this case, I do not because they don't give me anything else to go off of. There is no other number. We're going to follow the formula. The distance is the rate multiplied by time. So this time we're going to take this column and multiply it by this column. We're multiplying these two columns and writing them over here. So I have 5 times B minus 3. And I'm going to have 2.5 times B plus 3. Well, got the chart filled in, but now we need to write an equation. So the key to this problem is recognizing that the distance that we're going to go upstream, so the distance up, is going to be equal to the distance that we're traveling downstream. And hopefully that makes sense. In other words, you start off at the dock, you go upstream so far, and then you're going to turn around and come right back to the dock. So you end up in the same place you started. So they're equal to each other. So we're just going to set these two quantities equal. So 5 times B minus 3 is equal to 2.5 times B plus 3. Okay, let's distribute. So 5B minus 15 is equal to 2.5B plus 7.5. Moving all my B's to the left side. So 2.5 subtracted from 5 is 2.5B. That means I need to move the 15 to the right side, which is 22.5. And then we'll divide everything out. So 22.5 divided by 2.5 comes out to be. So just to make sure we answered the question's asking for the speed of the boat. And B, sure enough, is the speed of the boat. So the boat is traveling at 9 miles per hour. And that's a uniform motion problem. They can be kind of quirky because you might have that third row and you might not. So take them slow, fill in the chart.